So in this module, we're going to cover multiple regression with qualitative information, or with qualitative kind of variables. So qualitative variables or information. So oftentimes we kind of call these qualitative variables kind of dummy variables or binary variables because they take kind of 0, 1s. So qualitative information is often coded as binary, or maybe I'll say a binary variable. So it can take on, 0 or 1. So we could have this x variable x1, and it takes on two values, 0 or 1. And so we usually think of kind of it being natural what the 0 refers to. Usually we think of that as maybe like false and true. So if we had a binary variable, whether someone's employed or not, if that was our variable, 1 means the person's employed. So it means this variable is true where they're employed, and 0 would mean that they're, unemployed. Or I guess out of the labor market as well. Or alternatively out of the labor market, right? That would kind of take both of those rather than just maybe just being unemployed. Out of labor force or something. Okay, so a lot of times we're gonna see these kind of variables in economics. So let's say we're interested in discrimination, or well maybe we categorize things as a variable as male, and that's going to equal 1 if the person identifies as male, or if they're identified in the data set as male, and 0 if not. Or we could have a variable female that equals 1 if the person identifies as female, and 0 if not. We often call these dummy variables. So you'll see that term used a lot, called dummy variables. So if you see dummy variables, it's referring to the same thing, these binary variables that take 0 or 1. And you definitely hear dummy variable when we're going to cover the dummy variable trap. It's kind of a classic name for a certain multicollinearity or perfect multicollinearity that comes up in these situations. But let's erase this board and start off by talking about what happens if we use one of these binary variables as one of the independent variables in our regression. So let's look at binary variables as one of the independent variables. So a binary or qualitative variable as an independent variable. So let's think of an example. So maybe we're interested in wages. We always seem to be interested in wages and education in this class. Beta 0, and then I'm going to use a delta as my parameter just to demonstrate it's a dummy variable. You could use beta, you could make that a beta 1 instead, or whatever you want. You're just trying to keep the same kind of nomenclature as your book. So delta 0 plus, let's say, beta 1 times education. Let's say we ran this regression. Well, let's think about what this means. That means if this person identified as female, so if this variable equals 1, essentially what we're seeing is this equal 1, so we're seeing that, if they identify as female, their intercept is going to be these two parameters added together. Whereas if they didn't identify as female, then we just get wage equals beta 0 plus beta 1 times education plus U. So we see that this kind of delta here is kind of capturing the difference between the two. And if we assumed, and hopefully I'll have some room over here, maybe below, if the expectation, so let's imagine this is properly specified model, probably isn't. If the expectation of U, given our two variables, which are education and female, you know, if we didn't have any omitted variable bias and this regression was properly specified, then we'd have, if we wanted to draw out what our regressions look like, then, you know, we could have, let's turn the page here, we could have wage on this y-axis, hopefully that still comes up. And we have education on our x-axis. Well, what's happening here is that we have two different intercepts. One for those who identify as female and one for those who identify as male. So let's make an assumption about the sign of delta. Let's say delta 0 is less than 0, so it's a negative. That means our line for people who don't identify as female is the intercept is beta 0, the slope is beta 1, and this line is beta 0 plus beta 1 times education. So that's essentially what the regression line looks like for people who don't identify as female. Now for those who do identify as female, the intercept is beta 0 plus delta 0. The reason why it's below is because delta 0 is negative, and the slope is beta 1. So this is the regression line for those who identify as women, or as female, I should say. So notice that what this dummy variable is doing is changing the intercept for certain groups. And whether that intercept is above or below the old one depends on what sign. The sign, and I guess like how far below, it depends on the magnitude of the parameter on our dummy variable.